really quickly revisit the problem on the board, because I had to look at it for a second and figure out what the problem was. And I told you the problem was the box was too light. So it's an interesting case in point. When you end up with a negative normal force, what does that mean?
It's going.
It means it's actually flying up through the ground. If you ended up after resolving your forces with a negative gravitational force, what would that mean? Meaning you were shoving it down into the surface. So, you know, paying attention to what those numbers mean. So I had to make the box a little bit heavier so that our people couldn't shove it up into the atmosphere here.
Make the box a little lighter, didn't you?
No, I made the box heavier.
From 10 to 100, I think it's a little bit heavier.
10.
Oh, I thought it was 150.
No, the force
is
150. Yeah. So in this case, let's look at how this changes the kinetic friction. So here we have Fn equals Fg minus F of Py, 981 newtons minus 150 newtons times sine 45.
So you're just finding the normal force and plugging it into the other equation to find the kinetic. Okay.
So here our normal force is 874.933, etc. newtons. So it's less than gravity now because we've got this force pushing upward. Well, if we said that our coefficient of friction between this surface and this box was 10, then we have 10 times 874 I got problems with my numbers again. What happens when I pull numbers out of thin air? Okay, here we go. The coefficient of friction is 0.10. 0.10. So then our force of kinetic friction is going to be 87.49, etc. newtons. Okay, so the thing to look at is, does that force, I mean, obviously that force of kinetic friction has to be less than the applied force, or the thing is not moving. Okay, so, and I've forgotten tossing that out there. Your coefficients of friction are typically going to be fractional. They're going to be less than 1, so you're going to have, 0.7, 0.3, etc. You get them to really high coefficients of friction. Those are pretty crazy. All right, now let's look at what our kinetic friction is going to be here. Remember, the box has the same mass. We're applying the same force on it. We're just applying it in a different direction. So let's do a quick F of n here. We have our 981 now plus, and it'll be the same number, that 106. So 981 plus. So now our normal force is 1087.06, etc. Okay, so in this case, here let's go ahead and label our force of kinetic friction. F sub k here is with 3 sig figs. 2 sig figs. It's 87 newtons. And over here, we plug these numbers back in. So we have our 0.10 for our coefficient of kinetic friction times our 1087.06. Our force of kinetic friction here, whoops, is 109 newtons. And actually my sig figs are wrong there, but you'll just have to forgive me this once.
Would you forgive us on the test this once?
No, I would not.
Oh,
Exactly.
Double standard.
I'm not forgiving you.
Blatant double standard. Okay, fine. 110 newtons. There. You happy now?
Yay.
Okay. So, same box, same applied force, different applied direction. look at how much the force of kinetic friction can increase based on the direction in which you're pulling something. This is going to be highly relevant to your lab on Tuesday with your favorite holiday things. You'll see why. Okay.
Are you gonna just
Um,
kill these
Pardon?
food? Is it still gonna be edible after this?
It will still be edible after the lab.
Okay.
All right, we're going to